Good day, students. Today, we want to solve problem under differentiation involving Pascal triangle, and also we are going to make use of first principle in solving this differentiation. We have the general method in which we use in solving the differentiation, but sometimes students find it difficult when you are solving a problem like this. But what we need to do is to settle down, pay attention at the way I want to solve it, and you will notice that it's a very simple way of solving differentiation, but it's a long process. Is that okay? That's why WAEC, an exam like WAEC, they always specify that you should use first principle in solving it. If you use any other way in solving it, you'll be marked wrong totally. Okay, but you can use general method, which is y equals to ax raised to power n to confirm it. Now, what do you mean by that? When you differentiate this n, you come here, dy over dx. You are differentiating y with respect to x. It's now be a multiplied by n, x n minus 1. You can use this method, general method, to confirm if the first principle that we use is really correct. Now let's now go ahead. Let's start with the first one. Normally, if you want to differentiate this, you should have the general method. If you want to differentiate the first one with the general method, you have, let me see, you have y equals to x squared plus 2. That's it. Okay, this one is y. Take it to be y. Y equals this. Likewise, we have this. B plus y equals to that. Y equals to this. Y equals to that. Y equals to that. Now let me see. Let's use the general method to see what you are going to get, so that when we use the first principle method, you now see and compare the two. It must be the same. Now the y over the x here, 2 will come to the front. There's 1 here. That is 2 times 1 x 2 minus 1. When you are differentiating a constant, this is 0. When you are differentiating 1,000, 1 million, this is 0. Now plus 0. Now the y over the x equals 2 times 1, that is 2. X 2 minus 1, that is 1. Let's leave it like that. Differentiation of this is 2x. Now let's use Pascal. Let's see the Pascal triangle. Let's see the Pascal triangle. The Pascal triangle that we're going to be making use of is this 1. Start with 1. Bring 1 here. 1 here. Just shift triangle, like a triangle. You know, the triangle is of this form. Now 1, 1, 1, 1 plus 1, 2. The next one, you bring 1 here. 1 plus 2, 3. 2 plus 1, 3. You bring the last one here. So that's forming a triangle, like a triangle. You have 1, bring 1 here. Okay. Let's just form a triangle. Bring shift like this. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. We bring another one here. This is what I'm going to be using as we solve the differentiation with the first principle. Okay. Now let's now see. We want to differentiate with y with respect to x. We are going to introduce the y, the x into it. Okay, that's change in y plus y. It is a change in y plus the y that you have equals to x plus change in x, delta x, now square it. You see, you have y here already. Introduce delta y. And also you have x here, introduce delta x. As y is changing, x also is changing likewise. Okay, now constant, it will now have that change because it's a constant. It's a constant. Don't introduce change to the constant. Don't. Now let's now go ahead. You see that this one is squared. You are picking this 1, 2, 1. This one, you are not picking here. You are only using that one here. If you are using this one, let me say you are having something like this: y equals to x. That one, this one is applicable to this. That now dy dx equals to 1 will come to the front. 1 times there's 1 here, times 1, there's 1 also here. 1 minus 1, which is 1 x is what, 0, which is equals to 1 times 1. Anything raised by 0 is 1. It's 1. Okay? We are differentiating x. You just have 1. Is that okay? Well, when you are differentiating the constant, you have 0. Now let's go ahead. Since you are having 2 here, you are picking these 2. When you are having squared, you pick the second one. When you are having cube, you pick the third one, and so on like that. Okay? Now let's now continue. dy plus y, because this square and this one is increasing. If this square is decreasing, this one, the x will increase. Just take note like that. When x is decreasing, the x, if x is decreasing, the x will be increasing. That's what I'm saying. You are picking this first, which is 1, to be at the coefficient, which is x squared. Is that okay? The x will follow it, the x. Is that okay? X squared, the x, plus the next one, this one will reduce, x. You now introduce this 2. Now it becomes 2x, the x. Is that okay? So the first one will not have the x. You have x squared first. X squared. But there's 1 here. The next one will be plus 2. This one will now reduce. As it's reducing, this one will come in. The x. Is that okay? And plus, see this one now, see that it's from 2 to 1. This one coming. And plus the x squared. You understand? The first thing you do is that x will be squared first. Then the x will not surface. This change in x will not surface. Plus this one is here, but it's invisible. 1 times x squared will give you x squared. The next stage is to introduce 2. When you introduce 2, from 2 it comes to 1. The x will come in. Is that okay? You see that this x squared from 2 to 1 and this one from 1 to 2. As it's reducing, the x is increasing. That's the method. Now take the y to the other side. No, take y to the other side. Don't forget that our y, if I started from the first one, y equals x squared plus 2. X squared plus 2. Now the y equals x squared plus 2x plus 2x dx plus dx squared minus y. What's our y? This is our y. Now the y equals x squared plus 2x dx plus 2x dx plus dx squared minus what's our y? Y is x squared plus 2 plus 2. Okay, and don't forget that we have here, we have 2. We have 2 here. Before then, we have 2. Sorry, we have 2 here. This expression is for what's in the bracket. Look, this 2 is here plus 2. We have dy equals x squared plus 2x dx plus dx squared plus 2 minus y. Now the y equals x squared plus 2x dx plus dx squared plus 2 minus what are y? And see, we are doing this one first. X squared plus 2. Now the y equals x squared plus 2x dx plus dx squared plus 2 minus, open the bracket, minus x squared minus 2. If you look at it very well, x squared will cancel x squared because this x squared is minus x squared, cancel out. 2 plus 2 minus 2 is cancel out. You are left with dy equals 2x dx plus dx squared. Let's factorize what's common. The x is common. We have dy equals dx, open bracket, 2x plus 1 dx to be inside. Divide both sides by dx, 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 dx cancel dx. We have dy over dx equals to 2x plus dx. Okay? Now limit dy over dx, limit dx tend to 0 of over 2x plus dx. In any way you see dx, put 0 there. You now change this delta to small letter dy over dx equals to x. Okay? Now, what we need to do, let's confirm with the general method. Let's differentiate y equals to x squared plus 2 dy over dx. I told you that we are using y equals to ax raised to power n, dy over dx equals a multiplied by using this y equals to ax raised to power n, dy over dx equals a multiplied by n comes to the front, x n minus 1. That's general method. let's confirm, equals to 2 will come to the front, 2 times 1, there's 1 here, but it's not visible, it's invisible. Okay, time x, 2 times 1, x raised to power 2 minus 1 plus, I told you when you are differentiating constant is 0. dy over dx equals 2x, 2 minus 1 is 1. You have 2x, which is the same as what you have here. You can confirm it with the general method. Okay? That is that. The second one is this. Let's see the second question. We have y equals 2x squared plus 3x. Let's do the general method to be a guide for us. Y equals to 2x squared plus 3x. Let's differentiate dy over dx equals 2 times 2 x raised to power 2 minus 1 plus 3 times 1 x raised to power 1 minus 1. We have dy over dx equals 4x plus 3 times x raised to power 0 equals 4x plus 3 times 1. Anything raised by 0 is 1. Just 4x plus 3. 4x plus 3. Now, when we do our differentiation with first principle, we must get what is this expression. We must get this expression. This is our dy over dx. We use the general method. But don't use, when you are asked to use first principle, don't use this method. But you can solve it in a rough paper to be a guide for you to get the same thing. Now let's not go ahead. T squared, we are picking second stage. We have y plus dy equals 2, open brackets, open brackets, x plus dx squared. See, I put the 2 outside what is common to everything, common to all, plus 3, open brackets, since you're having x, x plus dx. Dx will always follow x. You can see that this x is squared, that's why I put x plus dx and I square it. But 2 is a constant, that's why I brought the 2 out. Now y plus the y equals 2, open brackets. Now have x squared first. The x will now surface here, but as it's reducing, the x will come in. Plus, don't put, now go back, because of this squared, come to the second stage. These 2 now stay at the front. X has reduced, dx will come in. As it's reducing by 1, dx will come inside. Is that okay? Plus, this one will not show again, because x from x squared to x raised to power 1 to nothing. Is that okay? X will now surface here. That's 2, 1, 0. Now you now have the x squared. Close your bracket. Plus 3x. 3 we multiply this as 3 times x plus 3x plus 3 dx plus 3 dx. You use the 3 to open the bracket. Now y plus dy equals, let's open it. Now 2 times x squared, that's 2x squared plus 2 times 2, 4x dx plus 2 times dx squared, that's 2 dx squared. Don't rush, just put gently. But plus 3x plus 3 dx. Now, what we need to do is to take y to the other side. Y, positive y turn to negative y. The y equals 2x squared plus 4x dx plus 2 dx squared plus 3x plus 3 dx minus y. Don't forget the expression for y is this. Now the y equals 2x squared plus 4x dx plus 2 dx squared plus 3x plus 3 dx minus, what's our y? Open bracket, 2x squared plus 3x. Now let's open this bracket. The y equals 2x squared plus 4x dx plus 2 dx squared plus 3x plus 3 dx minus 2x squared minus negative and positive, that's minus 3x. These 2x squared cancel, minus 2x squared plus 3x cancel, minus 3x. You have dy equals 4x dx plus 2 dx squared plus 3 dx. Let's factorize dx out. Dy equals dx, open bracket, 4x, okay, plus 2, 1 dx will be there because 1 is already out. 2 dx plus 3. Is that okay? If you like, you can put dx here. Dx, divide both sides by dx. Dx cancel dx. Now you have dy over dx to be equal to 4x plus 2 dx plus 3. Limit as dx tend to 0. Anywhere you see dx, introduce, you put 0 there. Now dy over dx, change it from delta to small d, equals to 4x plus 2, from bracket 0 plus 3. Dy over dx equals 4x, 2 times 0 is 0 plus 3. You can see it. Now we are getting what you have here. This is what's called first principle. Okay? Now, let's see the other question. The third question goes thus: y to be equals to x squared plus 3x minus 2. You now have y plus dy equals to x plus dx, close the bracket and squared, plus 3 open bracket x plus dx minus 2. Now let's do the normal general let's do the differentiation using the general method. Y equals x squared plus 3x minus 2. dy over dx equals 2. We come to the front, x 2 minus 1 plus 3 times 1, x 1 minus 1 plus 0. Because minus 2 is a constant, comes to 0. dy over dx equals 2x, 2 minus 1, 1, 2x plus 3 times x is equal to 0 equals 2x plus 3 times 1 equals to 2x plus 3. Now when you differentiate this, what you have with the general method is what you have a 2x plus 3. This is what we expect to get. We expect to get this when you use the first principle. Let's go ahead. Y plus dy equals x squared. Tell you that when you are doing the first one, put the first one down, the dx will not be there. But when it's reducing by 1, dx will come in. As dx is decreasing, as the x is decreasing, the dx, the change in x is increasing. Okay? Take note of that. Plus, using this we call the square plus 2. Is that okay? X dx plus this x will not come in again, plus the x squared. Let's use 3 to open the bracket. 3x plus 3 dx minus 2. This one is not there. Please take note. Okay. Now y plus dy equals x squared plus. Okay, let's now take y to the other side. So now we have dy equals x squared plus 2x dx plus dx squared plus 3x plus 3 dx minus 2 minus y. We have dy equals x squared plus 2x dx plus dx squared plus 3x plus 3 dx minus 2 minus, what's our y? Let's see our y to be x squared plus 3x minus 2. Now dy equals x squared plus 2x dx plus dx squared plus 3x plus 3 dx minus 2. Let's open the bracket, minus x squared minus 3x minus negative is positive plus 2. Let's see what we cancel out. X squared cancel this x squared plus 3x cancel minus 3x minus 2 cancel plus 2. We are left with dy will be 2x dx plus dx squared plus 3 dx. Let's factorize. Dy equals 2x plus dx plus dx plus 3. Close the bracket and pull dx outside. We divide both sides by dx. By dx cancel dx, are left with dy over dx equals 2x plus dx plus 3. Limit as dx tends to 0. You have dy over limit as dx tends to 0, introduce 0 here. Okay, plus 0. That dy over dx equals 2x plus 3, which is what we have here, 2x plus 3. Is that okay? Now let's move to the next question, which is D. The next question is when you have the x to be cubed, which is the D part, you are having y to be equal to x raised to the power 3 plus 2x plus 1 plus 1. Okay? Plus 1. Now, y plus dy. Now let's do the differentiation with the general method to see what we are going to get. Y equals x raised to the power 3 plus 2x plus 1. Now, dy over dx equals 3x, 3 minus 1 plus 2 times 1x, 1 minus 1 plus 0. Dy over dx equals 3x squared plus 2x to the power 0 equals 3x squared plus 2 times 1, because x over 0 is 1, equals to dy over dx equals 3x squared plus 2. Now, when you do your differential with 3x squared plus 2, if you don't get it, means that you are wrong. Okay? Now, y plus dy equals x plus dx, close the bracket, cube it, plus 2 into x plus dx plus 1. Y plus dy equals, you are having x raised to the power 3. You come to this, you are picking this third line because of the cube, plus, be very careful where you are doing it, it will reduce by 1. That's 3x squared, dx will come in, dx, followed by the next one, plus 3, from 3 to 2, from 2 to 1, 3x, dx squared, plus 1, this x will not be there again, you are having plus dx cubed. See that as x is decreasing, dx is increasing. Look at this, from 3 to 2. Now let's you have from 3 to 2 to 1 to nothing. It's like 3, 2, 1, 0. You don't need to put this one and the 0, just it disappears. The x disappeared from 3 to 2 to 1, nothing. X is not more showing. Y, as it's going down, dx coming, dx squared, dx raised to power 3. Now we now have plus 2, use to open the bracket, 2x plus dx plus 2x plus 2 dx plus 1. Take note. take y to the other side. Dy equals x raised to power 3 plus 3x squared dx plus 3x dx squared plus dx to the power 3 plus 2x plus 2 dx plus 1 minus y. Now replace y with the expression for y. Now dy equals x is for 3 plus 3x squared dx plus 3x dx squared plus dx raised to power 3 plus 2x plus 2 dx plus 1 minus y. What's our y? Our y is minus x raised to power 3 plus 2x plus 1. Dy equals x raised to power 3 plus 3x squared dx plus 3x dx squared plus dx raised to power 3 plus 2x plus 2 dx plus 1 minus x raised to power 3 plus 2x minus something bracket minus 2x minus 1. Okay, now let's cancel out x raised to power 3 cancel minus x raised to power 3 plus 2x cancel minus 2x minus 1 cancel plus 1. You're having dy equals 3x squared dx plus 3x dx squared plus dx raised to power 3 plus 2 dx plus 2 dx. Now let's factorize the x out. Dy equals 3x squared plus 3x dx plus dx squared. I'm reducing by 1 plus 2. Close the bracket and put dx outside. Now divide both sides by dx. Dx cancel dx. I left with dy over dx equals 3x squared plus 3x dx plus dx squared plus 2. Is that clear? Anywhere you see dx, that's a limit as dx tend to 0. Now write dy over dx equals 3x squared plus 3x into 0 plus 0 squared for dx, 0 squared plus 2 dy over dx equals 3x squared. 3 times 0, that's 0. 0 squared, that's 0 plus 2 dy over dx equals 3x squared plus 2. See that when you differentiate it with the general method to confirm, say confirm or check. Say check. When you have y equals x raised to power 3 plus 2x plus 1. Now general method, you have dy over dx equals 3x 3 minus 1 plus 2 times 1. This one here comes to the front. X 1 minus 1 plus 0. Constant is always 0. Dy over dx equals 3x squared 2 times 1 is 2, and x equals 0, n equals 0 is 1, equals 3x squared plus 2 times 1 equals dy over dx equals 3x squared plus 2, which is the same thing as what you have here to confirm. Please don't use this method when you have to use the first principle. See, this is the first principle to get to this point. Please use Pascal triangle. You must know your Pascal triangle. 1, bring 1 here, bring 1 to the other side, add the 1 together to give you 2. Bring 1 again to here, 1 plus 2 give you 3, 2 plus 1 give you 3, bring 1 here, 1 come here, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, bring 1 here. The same thing, continue like that. The power will determine the one you are going to use. Is that okay? If it is 3 to the power 4, you use the fourth line. Is that okay? 1, 2, 3, 4, the fourth line. Is that okay? Now let's solve the 5th question. Now, the E part, you have y will be equal to 3x squared cubed, 3x cubed minus 4x plus 3. That's it. Now, y plus dy equals 3 open bracket x plus the x cubed minus 4x plus 3. From here you have y plus dy equals 3, followed 1, 2, 3, come on the cube, that's in the third line, which is x will be cubed first, followed by plus 3 plus 3x squared, it reduces, ds will come in dx, plus 3, again 3 x, the x squared, see that the x is increasing as x is decreasing, plus this one is different, plus the x cube plus the x cube minus 4x plus 3. Now close it. Okay, so the bracket will be closed here because of this 3. This expression ends here. Now, so this one also, you are going to introduce your x dx, x plus dx plus 3. Now, y plus dy equals 3. Let's open the bracket, 3x cubed plus 3 times 3, 9x squared dx, 3 times 3 plus 9x dx squared plus 3 dx cubed minus 4x plus minus 4x minus 4 dx, so minus negative, we turn this positive negative, plus 3, lovely. Take y to the other side, the y equals 3x cubed, x cubed plus 9x squared dx plus 9x dx squared plus 3 dx cubed minus 4x minus 4 dx plus 3 minus y. Minus y, go to the other side. So having dy will be equal to 3x cubed plus 9x squared dx plus 9x dx squared plus 3 dx cubed minus 4x minus 4 dx plus 3 minus, open the bracket, what's the expression for y? That's minus 3x cubed minus 4x plus 3. You have dy to be equal to 3x cubed plus 9x squared dx plus 9x dx squared plus 3 dx, this was 3 minus 4x minus 4 dx plus 3 minus 3x cubed minus negative and positive plus 4x minus 3. Let's see what will cancel out. 3x cubed cancel minus 3x cubed plus 4x cancel minus 4x minus 3 cancel plus 3. We are left with dy equals 9x squared dx plus 9x dx plus 9x dx squared plus 3 dx cubed minus 4 dx minus 4 dx. Let's factorize. Dy equals 9x squared plus 9x dx plus 3 dx squared minus 4. Close the bracket and put your dx outside. Divide through by dx. Through by dx. Is that okay? Limit. Okay, let's rewrite it. Dy over dx equals 9x squared plus 9x dx plus 3 dx squared minus 4. That's the limit as dx tends to 0. Limit at dx tends to 0. Dx here will cancel dx. And you see dx, introduce your 0. 0. This one is squared here. Since we said limit at dx tends to 0, now change to dy, small letter d, dy over dx equals to 9x squared plus 9x times 0, that's 0, plus 0 minus 4. Dy over dx equals 9x squared minus 4. Now let's check in the general method. Now let's differentiate this. We have y equals 3x cubed minus 4x plus 3. Dy over dx equals 3 times 3, x 3 minus 1 minus 4 times 1, x 1 minus 1 plus 0. Dy over dx equals 3 times 3, that's 9, x squared, 3 minus 1 is 2, minus 4, x is equal to 0, equals 9x squared, 9x squared minus 4 times 1. dy over dx, dy over dx equals 9x squared minus 4. 9x squared minus 4. So this is general method. This is the first principle. Now let's solve the last question. Okay. Last question we are having f, that's y, okay, y equals to that, y equals 2x cubed minus 2x squared plus 2. If you do the normal differentiation, we're going to do it later. Let's be our guide. Let's do it somewhere else. You're having y to be equal to 2x cubed minus 2x squared plus 2. dy over dx equals 2 times 3 x3 minus 1 minus 2 times 2x 2 minus 1 plus 0. dy over dx equals 6x squared minus 4x minus 4x minus 4x. When you differentiate this, must get 6x squared minus 4x. Now let's go ahead. Y plus dy equals 2, open bracket. Since it's having cube, we're picking the third line, which is starting with x cubed. Okay? Don't forget that 2 is common to it, that's why I brought 2 outside. Plus x squared, the x is surface. But don't forget that you are having 3 plus 3. What you have here will be following what you are writing. Plus the next 3x 2 to 1, dx increases squared. Last one plus the x cubed. Okay. Minus 2, open bracket, because this one is being squared, we are picking this. That's x squared first, plus 2. Bring the 2 here, there's 1 here, it's standing for this, plus 2x, the x, isolate, decreases the x coming, plus the last one, the x squared, there's 1 here, plus 2. Now y plus dy equals, let's open the bracket, 2x raised to power 3 plus 2 times 3, that's 6x squared dx plus 6x, 2 times 3, that's 6x dx squared, 2 times this plus 2 dx cube, 2 dx cube. Now let's open this. The next one, minus 2x squared minus 2 times 2, that's minus 4x dx minus 2 times minus dx squared, that's minus 2 dx squared plus 2. Okay, let's take y to the other side. The y equals 2x cubed plus 6x squared dx plus 6x squared dx plus 6 6s squared dx plus 6x dx squared plus 2 dx cubed minus 2x squared minus 4x dx minus 2 dx squared plus 2 minus y. That goes to the other side. Y turns to minus y. The y equals 2x cubed plus 6x squared dx plus 6x dx squared plus 2 dx plus 2 dx cubed minus 2x squared minus 4x dx minus 2 dx squared minus 2 dx squared plus 2 minus, what's our y? Our y, let's replace it, having 2x cubed minus 2x squared plus 2. Please be very careful of the sign. Now you get it wrong. The y equals 2x cubed plus 6x squared dx plus 6x dx squared 6x dx squared plus 2 dx cubed minus 2x squared minus 4x dx minus 2 dx squared plus 2 minus, let's open the bracket, that's minus 2x cubed minus negative and negative plus 2x squared minus 2. Let's see what cancels out. This one cancels with this. Minus 2x squared cancel with 2x squared minus 2 cancel plus 2. We are left with the y to be equals to 6x squared dx, 6x squared dx plus 6x squared dx plus 6x dx squared 6x squared dx 6x dx squared plus 2 dx cubed 2 dx cubed minus 4x dx minus 4x dx minus 4x dx minus 2 dx squared. Now let's factorize. Let's factorize out. The y equals 6x squared plus 6x dx plus 2 dx squared. I'm trying to remove 1 dx from each of them, minus 4x minus 2 dx. Put the bracket and put dx. Divide both sides by dx. Dx cancel dx. Carry dy over dx. Dy over dx equals 6x squared plus 6x dx plus 2 dx squared minus 4x minus 2 dx. That's limit at dx tends to 0. Anyway, see dx, you put 0 there. That means that here, you put 0 here, put 0 here, limit at dx tends to 0, put 0 here, okay, and then put 0 here, here. Now, if you do that, you have to change to dy over dx equals 6x squared plus 6x times 0, 0 plus 0 minus 4x minus 0. dy over dx equals 6x squared minus 4x. Now let's check. Let's check. We are using the general method. In the general method, the y equals 2x is for 3 minus 2x squared plus 2. Now, the y over dx equals 3, we come to the front, 2 times 3, x3 minus 1 minus 2 times 2, x2 minus 1 plus 0. I told you that when you are differentiating a constant is always 0. Now, the y over dx equals 6. 2 times 3, that's 6. 3 minus 1, that's 2. 6x squared minus 4. X 2 minus 1, that's 1. As you see, you are not getting the same thing. Please, very careful when you have to see that it's very short way, general method very short. That's why in WAEC, we are always asked to use first principle. But this general principle can apply it when it comes in objective. This is the end of our class. Please subscribe to my channel so that you have access to the latest video. Have a wonderful day.